Again, we have no x-intercepts. We do, however, have a y-intercept at 0, 1. And then our vertical asymptotes, again, is just this equation of x is equal to a pi over 2 plus pi k, for k is in the set of integers. And that is our secant graph. So if we were to explain what's going on, it says, given any sine graph, describe how would you use it to graph the cosecant graph. So basically we're going to first graph our sine graph, and then we can go ahead and put in our asymptotes and then invert the graph. And it's the same thing for when we are graphing our secant graph. Just this time we're going to be starting out by graphing our cosine graph. So let's go ahead and look at examples. It says whenever you graph a cosecant, graph the related sine function first with all the changes, and then go ahead and graph your cosecant graph. So let's start by labeling our sine function. So I'm going to go ahead and look at this guy. I'm going to rewrite it as y is equal to 2 sine of a 3x. We know how to graph these. It looks like we have an amplitude of 2, we have a b value of 3. That means we're going to undergo a period change, so p is equal to 2 pi divided by 3. Our units then change to a 2 pi divided by 3 divided by 4. This becomes 2 pi divided by 12, and then it's going to give us a pi over 6. So start at 0 radians, we have pi over 6, 2 pi over 6, this is a pi over 3, 3 pi over 6, it's going to give us a pi over 2, and then we have our 2 pi over 3. Okay, we have an amplitude of 2. So there's our y-axis. Then I'm going to go ahead and graph out my sine graph with a dotted line. Okay, remember we have our asymptotes. Now we're going to go ahead and graph our cosecant graph. We have our asymptotes at 0, pi, 2 pi, and yada yada yada. So here's my first asymptote. There's my second. And there's my third. And then go ahead and graph your inverted graph. So there is my graph for y is equal to 2 cosecant of 3x. Cool, let's move on to the next one. We have y is equal to a negative cosecant of 2 times the quantity of x minus pi over 2. So here there's multiple things going on. I'm going to first rewrite it as y is equal to a negative sine of 2 times the quantity of x minus pi over 2. Okay, it looks like we're going to be flipping over the x-axis. We have a b value of 2, so we're going to have a period change, and then we are also going to go right pi over 2. So first start with your period change. We have p is equal to a 2 pi divided by 2. So our new period is pi. And our new units is going to be a pi over 4. So I would do some math down below. We have our original of 0, pi over 4, pi over 2, 3 pi over 4, and pi. Again, we are going right pi over 2, so I'm going to add pi over 2 to all of these values. So we're going to first start with pi over 2. I have pi over 4 plus pi over 2. This is going to boil down to a 3 pi over 4. I have pi over 2 plus pi over 2. This is just pi. 3 pi over 4 plus pi over 2 is 5 pi over 4. And I have a pi plus pi over 2. This is going to give me a 3 pi over 2. Again, with these guys, I have to find common denominators to figure out those new values. Okay, so now I can go ahead and write out my new x-axis. I have pi over 2, 3 pi over 4, pi, 5 pi over 4, and a 3 pi over 2. Our amplitude is 1. Now we have all those values, so we can go ahead and graph out our sine. So again, we had to start at pi over 2. So it looks like, and we're flipping it, so this is our sine graph. I'm now going to go ahead and fill out my asymptotes. Here's my first one. It's wherever my sine graph hits the x-axis. There we go. And now I'm going to invert my sine graph and go ahead and graph my cosecant graph. And we are done. Alright, so when we are graphing our secant graph, we have to graph the related cosine function first with all the different changes, and then we have to graph our secant graph. So I have y is equal to negative 3 sine of pi x. So again, I'm going to rewrite this as y is equal to a negative 3 cosine of pi x. It looks like we're going to be flipping over the x-axis. I have an amplitude of 3. I have a b of pi, so we are going to undergo a period change. P is equal to 2 pi divided by pi. So my new period is 2. And it looks like my new units are 2 over 4, which gets me to 1/2. So I'm going to start at 0. We have 1/2, 1, 3/2, and 2. Our amplitude is then 3. Okay, and I'm going to go ahead and graph this negative 3 cosine of pi x. Oops. So there is that graph. Something like that. Now you can go ahead and graph out your asymptotes. So again, it's wherever this cosine graph is hitting our x-axis. So I'm going to go ahead and graph those. And then you can just take those points and just draw out your parabolas, and here we are. We have our y is equal to a negative 3 secant of pi x. And we are done. Okay, the last example, we have y is equal to secant of 2x plus 1. So be careful, this is not one of those examples we have our c, so we are not moving left one, right? This is when we have our d value is up 1, so we're going to go up 1 in our graph, so we're going to have new midline. And then we also have a b value of 2, so we are going to undergo a period change. We have p is equal to 2 pi divided by 2, so our new period is pi, and then our new units is going to be a pi over 4. So I have 0. I'm going to first write it as y is equal to cosine of 2x plus 1. So we have 0, we have pi over 4, we have pi over 2, 3 pi over 4, and a pi. Okay, I am going to have 1 and negative 1. Really, that's what our amplitude is. However, we have a new midline, so I'm going to move up everything 1. So there's a new value of 2 up there. And I'm going to go ahead and just graph out that cosine graph. So we have 1, middle, down, middle, up. So there's my cosine graph. Now I'm looking at my new midline, and it's wherever we have an asymptote, it's wherever our graph of cosine hits our new midline. So there's my first asymptote, and there's my second. Okay, and then I'm just going to go ahead and graph out my parabolas. And here we are. All right, we finished.